Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is the last class before the Christmas break. So I'll be off for 2 weeks. So WASA will be closed for the next 2 weeks for Christmas break. So there won't be anybody here to receive your work. So hang on to it until after the break. If you send it out today, we will get it. And if you work on it over the break, I'm sure the learning centers are closed in the community, so you'll have to hang on to it until after the break. To participate in classes, you can join via radio or Zoom. The instructions are in your study guide. And all PLAR Math students are welcome to attend classes, so it doesn't matter how you signed up, you can still attend the radio Zoom classes, IL or radio Zoom students. To contact me, you can use email, phone, or send a message on Facebook. And the PLAR English classes from last term are still available on YouTube. So if you're working on your PLAR English, you can go there and watch the classes still. Just a reminder that you're never withdrawn from PLAR. So once you sign up at the beginning of the year, you're in it until you can work through the terms until we close in June. And then in September, you just need to reapply for it. Okay. Just a reminder that PLAR students can have the option, of writing the culminating activity instead of doing the lessons and key questions. So even if you've completed some of the lesson work and submitted it already, you can choose to do the culminating activity instead of finishing those key questions. And then if you pass the culminating activity, you get your missing credits. And you don't have to do the lessons and the key questions. You just move on to the next subject. If, however, you're not successful with the culminating activity, then you will have to go through the lessons and complete the key questions. And then at the end, you will write another culminating activity. So it's up to you which way you want to do that. If you are doing the lessons, in your lessons you will notice that there are two types of questions. There are support questions and there are key questions. So the support questions are the practice questions that you do before you do the key questions. So as you read through the lessons, there will be a section that you'll read, then a support question, then another section, another support question. So as you're working through, do those support questions, and near the end of the lesson, right before the key questions, you will find the answers to the support questions. Check your answers against those, and if you're getting most or all of those questions correct, then you move on to the key questions, and those are the questions you send to me for marking. Those are the ones that have the marks. Support questions don't have any. Okay, so you should start working on your key questions. So like I said, if you're doing well with the support questions, do the key questions and submit them right away. If you're struggling with the support questions, contact me, watch the classes for some help, and then try the questions again. Okay, ways to submit your work. The first way, of course, is to give it to your DEC, and your DEC will send it out to us here in Sioux Lookout. If you don't have a learning center or a DEC, or your DEC is away, then you can submit your own work by scanning and emailing it, if you have access to a scanner, to the studentwork@nnec.on.ca email, and make sure you CC to me as well. Or if you have access to a fax machine, you can fax to our toll-free number. One thing to remember if you are submitting your own work is be sure to write your name, subject, and your teacher's name on your work, because otherwise when we get it, we don't know who it belongs to, so we can't give you your marks. So make sure your name's definitely your name. You can put the subject and your teacher's name on it as well, but again, check and make sure your name is on there, and you should either write your first name on every page or initial every page as well, in case again something gets messed up. Okay, another way, if you don't have access to a scanner or a fax machine, you can use your smartphone. With your smartphone, you can either take photos of your work or scan your work and then email it to that same student work email and CC it to me, or you can send your work via Facebook Messenger. Send the pictures or the scan. Also, if you are in Sioux Lookout or you live in the surrounding area and you come to Sioux Lookout, you can use our outdoor mailbox, which is located in the parking lot, the side of the building toward the post office. Or you can just knock on the front door and give it to the person that answers the door. You can also use Google Docs to complete your work, and then you can send me the link. Again, make sure your link is shareable, otherwise I can't open it. And the last way is to use Google Classroom. So if you want to go paperless, you can do all your work online and submit it online as well. At the end of term 1B, as at the end of every term, we have 2 student draws. One is for students who earned a credit during that term, and one is for students who submit work during the term. So for every lesson that you submit, your name will be entered into a draw. So make sure that you submit your lessons regularly so that your name will be entered into the draw. The more lessons you submit, the more chances you have to win. Same thing with credits. The more credits you earn, the better your chances of winning. All right, so let's do a review of what we covered in class on Tuesday. So on Tuesday, we finished up lesson 2, and we talked about circle graphs. So a circle graph, or sometimes it's referred to as a pie graph or a pie chart, shows how parts of something are related to the whole. A circle graph is divided into sections, just like you cut up a pie or a cake, you divide it into sections, where each sector represents a particular category. The entire circle is one whole, or 100%, and a sector of the circle is a part of that circle. So the title of a circle graph tells us what the graph is about. So, it might be favorite flavors of ice cream, or favorite school sports, or percentage of students who attended classes regularly, or something like that. So it will tell us what the graph is about. Then the sectors, or the sections, show what percentage of the whole is being represented by each category. And then we have labels that identify the facts for each category. We can use the circle graph to answer different questions. So here's an example of a circle graph. The title of this graph is Music Preferences of the Students at Adams School. So the different types of music. We have classical, country, alternative, rock and roll, and rap. And so the circle for music preferences is divided into 5 different sections or sectors, and each sector represents the percentage of students that prefer that type of music. So a poll was taken to find the music preferences of students at Adams School. Each student voted only once. The results of this poll are displayed in the circle graph below. So we can answer questions based on that. So for example, what is the circle graph about? It's about music preferences. So you would use a complete sentence to answer these questions. The circle graph is about and it's about music preferences. Or you can say music preferences at Adams School. How many sectors are in the graph? Well, I already answered that question. There's rap, classical, country, alternative, and rock and roll. So there are 5 sectors. Which type of music do students prefer the most? So we're looking at prefer the most, so that will be the highest percentage. So we've got classical 10%, country 12%, alternative 15%, rock and roll 28%, and rap 35%. And when you just look at the circle, you can see that the light purple or blue is the largest section of the circle, so that would be the type of music that students prefer the most, so that would be rap. Okay, which type of music do students prefer least? So that's going to be the smallest sector, which is, if you look at it, classical. So we can look at the size of the circle, or the sector, sorry, or we can look at the percentages. Number 5, what percentage of students prefer alternative? So alternative, 15%. Number 6, what fraction of students prefer rock and roll? So our graph is in percents, but this question is asking about fractions. So what fraction of students prefer rock and roll? So here's rock and roll, it's 28%. So what we have to do is change that percent to a fraction. So remember that the whole circle is 100%, and percent means out of 100. So our fraction is 28 out of 100. And if we reduce that, it'll be 14 out of 50. And we can reduce it even further. Divide by 2, 7/25. So the fraction of students that prefer rock and roll is 7/25. And number 7, list the categories in the graph from greatest to least. So greatest would be rap, then rock and roll, alternative, country, and then classical. Okay, so just an example of the different types of questions that can be asked about circle graphs. All right, so that's lesson 2 done, and so we're going to just start lesson 3 today. And lesson 3, we're starting to get into algebra. So we're looking at exponents, order of operations, polynomials, and expanding expressions. Today, we are going to look at the exponent rules and order of operations. All right, so exponents and power. So there's information on exponents beginning on page 3 of your lesson. So page 3, 4, 5, 6, 7. Whoops. And then page 8 is support question number 2. And page 9, support question number, or sorry, still continues on support question number 2. Okay, so again, read through the information and do the support questions. Check your answers at the end. And if you're doing well, move on to the key question. Okay, so exponents. So before we start looking at exponents, we need to know some of the terminology that goes along with exponents. So terms, factors, and coefficients. We've already met factors, and I believe we've already met terms. So terms are single numbers, like 5, variables or letters, like y, or the product of a number and a variable, like 9a. 9a means 9 times a. So you multiply 9, a number, times a letter, you get a number-letter combination. Factors. A factor is one part of a product. So factors are the numbers that you multiply. So in the term 8x, the factors are 8 and x. In the term c, d, e, the factors are c, d, and e, because the two things that are being terms that are being multiplied in c, d, e are c times d times e. Okay, coefficients. A coefficient is the number that's multiplied by a variable. So the variable is a letter. So for example, in the term 14c, the coefficient is the number 14. In the term g, so just the letter by itself, the coefficient is 1, because it's understood that it's 1g. So we don't put it in, we just put the letter there. You can, if you want to, put the number 1 in there, but you don't have to. Name the coefficients in the following terms. So in the term 14f, the coefficient is 14. It's the number. In negative 2y, the coefficient is negative 2. It's not just 2, it's negative 2. In the term half x, the coefficient is a half. And in the term negative 32y, the coefficient is negative 32. Okay, so the coefficient is the number that's in front of the letter. Okay, so now powers and exponents. So we know how to multiply 5 times 5. We just go 5 times 5 is 25. That expression, 5 times 5, can be written in a shorter way using exponents. So instead of writing 5 times 5, because we're repeating the numbers, we can write 5 to the power of 2. An expression that represents repeated multiplication of the same factor is called a power. So this 5 to the power of 2 is called a power. The number 5, right here, big one, is called the base. The little 2 is called the exponent. Together, they are what we call a power. So here we've got 3 to the first power. Different ways of writing it. So the first one, 3 to the power of 1, this is called exponential form. Three to the first power is how we read it, and then 3 is called standard form. Repeated multiplication. Okay, so 3 to the power 1, 3 to the first power, or 3 to the power of 1, and repeated multiplication because the 1 exponent tells us how many times to multiply the 3. So 1, there's only 1 3, so 3 is how we would write that in repeated multiplication. 4 to the second power, or 4 squared, if we have a 2, we usually say it's squared, is multiplying 4 2 times, so 4 times 4. 5 to the third power, or 5 cubed, is 5 multiplied 3 times. 2 to the sixth power, or power of 6, is 2 multiplied 6 times. So the exponent tells us how many times to multiply the base. So they are a short way to write repeated multiplication. So here, 3 to the fourth power is 3 times 3 times 3 times 3. 81, so once we multiply 3 times 3 is 9, times 3 is 27, times 3 is 81. That answer is what we call standard form. So 3 to the fourth power is exponential form. 3 times 3 times 3 times 3 is the repeated multiplication form. And 81 is the standard form, so the answer. Okay, example 1. Write 6 times 6 times 6 times 6 times 6 using exponents, first of all. Then read your answer aloud, and then write it in standard form. So the solution, when we multiply, as a single exponent is 6 to the fifth power. So we read it as 6 raised to the fifth power, or we can just say 6 to the fifth power. And in standard form, when we multiply 6 times 6 times 6 times 6 times 6, we get 7,776. Example 2, write 8 times 8 times 8 times 8 times 8 times 8 times 8 using exponents. So we write it out, and we count how many 8s there are. 1, 2, 3, 4, 5, 6, 7. And so it's 8. The base stays the same, and the exponent is 7. So it's 8 to the 7th power. And then the standard form, when we multiply that out, we get 2,097,152. Okay, so write 10 with the exponent of 3, 3 with the exponent of 6, and 1 with the exponent of 8 in factor form. So that's repeated multiplication. And then in standard form. So that means the answer. So 10 to the third power is 10 times 10 times 10. And standard form, 10 times 10 is 100. 100 times 10 is 1,000. So standard form is 1,000. 3 to the sixth power is 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5 times 3. And when we multiply 3 6 times, so when you're doing this, it's not 3 times 6. It's 3 times 3 times 3 times 3 times 3 times 3, which equals 729. So don't get mixed up and think this 3 times 6. It is not 3 times 6. Okay, last one, 1 to the 8th power is 1 multiplied 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And 1 times 1 times 1 times 1 times 1 equals 1. Okay, so that's exponential form, factor form, and standard form. So now there are, just like everything else, like for rules for adding, subtracting, multiplying, and dividing integers, and rules for adding, subtracting, multiplying, and dividing fractions, there are also rules for working with exponents. So the following rules apply to numbers with exponents of 0, 1, 2, and 3. So any number except 0 raised to the 0 power is equal to 1. So it doesn't matter what the number is. If it has an exponent of 0, the answer is 1. So 149 to the power of 0 is 1. Any number raised to the first power is always equal to itself. So 8 to the first power equals 8. Doesn't matter what the number is. If the exponent is 1, then it equals the base. If a number is raised to the second power, we say it is squared. Okay, so 3 with an exponent of 2 is read as 3 squared. If a number is raised to the third power, we say it is cubed. So 4 with an exponent of 3 is 4 cubed. Okay, so powers with variables. So variables, remember, are letters. So when we get into algebra, we start seeing more letters in the math. So b to the 5th power is read as b to the 5th power. It means that we're multiplying b 5 times, same as with numbers. Its value would depend on the value of b. So if we say that b is 2, so we say the value of b equals 2, then it's 2 to the 5th power, and we would multiply 2 5 times. The exponent applies only to the number that it is next to. Therefore, in the expression x y to the 4th power, only the y is affected by the exponent 4. So the y is multiplied 4 times, not the x. The x in this term is a coefficient of y. So, rules for simplifying exponents. So when we're talking about simplifying exponents, we are talking about having one exponent. So the first rule is called the product of powers rule. So when multiplying two bases of the same value, so in the example we've got 4 squared times 4 to the 5th power, so we've got the same base, 4 and 4. So this, when we do this, we keep the bases the same, keep the base the same, and then add the exponents together to get the solution. So the base 4 squared times 4 to the 5th power, the 4 for our answer stays the same. We take the exponents 2 and 5 and we add them to get 7. So 4 squared plus 4 to the 5th power is 4 to the 7th power. So just to explain that, so you can see what's going on, multiply 4 by itself 7 times to get the standard answer. So 4 to the 7th power, we're multiplying 4 7 times, and our answer is 16,384. So here's how the rule works. So 4 squared is 4 times 4, which is 16. 4 to the 5th power is 4 multiplied 5 times, which is 1,024. So 4 squared times 4 to the 5th power is 16 times 1,024, which equals 16,384. Or we could do it the way we just did it, keep the base the same, add the exponents, we get 4 to the 7th power, and then we multiply 4 7 times, and we get the same answer. Okay, so here's an example that's a little bit more complicated. So we've got 4x squared times 2x cubed. So in this case, what we have to do is multiply the coefficients together because they're not the same base. then keep the x the same and add the exponents. So we're actually multiplying the 4 and the 2 to get 8, and then we're doing x squared times x cubed, and that will give us x, 2 plus 3 is 5, to the 5th power. Okay, we'll get into that a little bit more later on when we look at multiplying monomials. Okay, so that was the product. So for multiplying powers, now we're looking at the quotient, so dividing powers. So multiplication and division, as we talked about before, are opposites of each other. Much the same, the quotient rule acts as the opposite of the product rule. So when dividing two bases of the same value, we keep the base the same. So 5 to the 5th power divided by 5 cubed, we keep the base the same. And then we subtract the exponents, 5 and 3. So 5, because the bases are the same, then our base in our answer is going to be 5. And we subtract. 5 take away 3 is 2. So it's 5 squared is our answer. And then we simplify it by multiplying. 5 squared is 5 times 5, which is 25. Okay, so do the same thing we did with multiplication. So 5 to the 5th power divided by 5 to the 3rd power. 5 to the 5th power, when we multiply 5 times 5 times 5 times 5 times 5, we get 3,125. And when we multiply 5 to the 3rd power, 5 times 5 is 25, times 5 is 125. If we divide those, we end up with our answer of 25. Or we can do what we did above, keep the base the same, subtract the exponents, and then 5 times 5 equals 25. Okay, here's another example. This one's a little bit more complicated. So 5 to x to the 4th power over 10x squared. So remember, fraction means divide. So just like the variables, so the like variables in the denominator cancel out those in the numerator. So you can see this by crossing out an equal number of x's from the top and the bottom of the fraction. So 5x4, so that's x times x times x times x over 10x2. Okay, so we're dividing. X divides by x, x divides by x, and we're left with just the 2 x's over 10. So then we simplify as we would with any fraction. So we can divide 5 and 10 as well. So 5 divides into 5 once. 10 divides by 5 twice, so we've got a half. And then we divide 4 divided by 2 is 2, so we end up with x squared. So we end up with x squared over 2. So you can leave it as 1x squared over 2 if you want to, but again, we don't need to put that 1 in there. We can just do x squared over 2. Okay. Number 3 is the power of a power. So we've done multiplying powers, we've done dividing powers. So this one is when we multiply a power by a power. So when it looks like this. So you've got a variable or a term inside brackets with an exponent, and then outside the brackets you have another exponent. Okay, that is a power raised to by another power. So in this case, when you have brackets there between the exponents, you multiply the exponents and you keep the base. So the x stays the same. Multiply 3 times 3 will give you 9. Okay, and here is the expanded equation to show you how it works. So x to the power of 3 is x times x times x, and that is also to the power of 3. So we have x times 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 x. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's that are multiplied, so x to the 9th power. And that, because it's a variable, it has to stay just like that. And then we have the power of a product rule. So when any base is being multiplied by an exponent, so you just have a base inside the brackets and an exponent outside, distribute the exponent to each part of the base. So that means you distribute it to the both terms, so the x and the y. So xy cubed is means the 3 goes with the x and with the y. So it's x cubed, y cubed. So this rule applies if there are exponents attached to the base as well. So even if the base inside, x squared, y squared, and then to the power of 3, or to the third power, we multiply 3 times 2 and 3 times 2. So x squared cubed is x to the power 6th power. Y squared cubed is x, y to the 6th power. Okay, and so just to show you that, so x squared, so with the third power outside, so x squared is x, so that cube, sorry, is x squared times x squared times x squared, and y squared times y squared times y squared. So we multiply them all, so x squared is x times x 3 times, y squared is y times y 3 times, and so we end up with 1, 2, 3, 4, 5, 6 x's, and 1, 2, 3, 4, 5, 6 y's. And when we're dealing with variables, you can't really write it in a standard form like you can a number. Your answer will always have an exponent in it. And then we have the power of a quotient rule. So a quotient simply means that you're dividing two quantities, and in this rule you're raising a quotient by a power. Like the power of a product rule, the exponent needs to be distributed to all values within the brackets it's attached to. So if you have something like x over y raised to the 4th power, then both of them end up with the power of 4. So x to the power of 4, y to the power of 4. We have the 0 power rule that tells us that any base raised to the power of 0 is equal to 1. Okay, so here's how that works. So we've got 4 cubed divided by 4 cubed. So 4 cubed, following the quotient of powers rule, subtract the exponents from each other. So 3, take away 3 is 0. So you're left with 4 over 4, and 4 over 4 is equal to 1. Any number over itself is always equal to 1. Okay, so the exponents cancel each other out because they're subtracted. 3 take away 3 is 0, and then you're left with 4 over 4, or whatever number. No matter how long the equation, anything raised to the power of 0 becomes 1. So something like 8 squared, x to the 4th power, y to the 6th power, and it's all raised to 0, then so 8 squared, we're multiplying because of this bracket, so that'll be 2 times 0, which is 0, so you'd end up with down here, so right at the bottom, 8 squared, 2 times 0 is 8 to the power of 0, 4 times 0 would be x to the power of 0, and 6 times 0 would give you y to the power of 0. So 8 to the power of 0 is 1, 0 to the power of x to the power of 0 is 1, y to the power of 0 is 1, so 1 times 1 times 1 equals 1. Okay, so it doesn't matter. If there is an exponent of 0, your answer will always be 1. Doesn't matter what the number is. Okay, so write each expression as a single power and then evaluate. So 7 squared times 7 to the power of 4. So here we're using the product rule. So our base is going to stay the same because we have the same base. And for the product rule, we add the exponents. 2 plus 4 is 6. So it's 7 to the 6th power. So this is writing each expression as a single power. So 7 squared times 7 fourths. We've got 2 powers there. We're multiplying them. Now we have a single power is our answer. And then we evaluate. So evaluate means we multiply. We multiply 7 6 times. So 7 times 7 times 7 times 7 times 7 times 7 equals 117,649. Okay, so that is the product rule. So here let's do E. So we've got negative 2 squared times negative 2 cubed. So what we have here then is same base. So our answer is going to be negative 2, and we're adding our exponents. 2 plus 3 is 5. So negative 2 to the 5th power And then we evaluate it by multiplying -2 times -2 times -2 times -2 times -2. I put brackets around here because otherwise it's confusing. So then you multiply it out. So using your calculator, you're going to put in 2, and then you're going to use a plus minus sign to give you a -2. So then you're going to multiply times 2, and that -2 5 times, which will give you -32. Okay. Let's move down to number 2. Write each expression as a single power, then evaluate. So now we're dividing. So when we divide, we've got the same base, so our base stays the same, but we subtract our exponents. So 6 take away 4, 8, 6 take away 4 is 2 to the 8 squared, sorry, which is 8 times 8, which is 64. So we have simplified to a single power, and we have evaluated. Okay, so that's what that means. Okay, same thing with negative numbers or decimals or whatever. So -9 to the 7th power divided by -9 to the 6th power. Our base stays the same, -9. 7 take away 6 is 1. So our answer is -9. Okay. Number 3, write expression as a single power, then evaluate. So now this one is the power rule. So you'll know it's the power rule because there are brackets. So write it as a single power first of all. So 2 stays the same, and we multiply the exponents. 2 times 4 is 8. So 2 to the 8th power, and then we multiply 2 8 times. 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 times 2 is 128, and 128 times 2 is 256. Okay, so single power, evaluated. Okay, next use the exponent laws to simplify each expression, then evaluate. So these are mixed up. So sometimes you might be presented with a problem where you have 2 things to do, division and multiplication. So you do your multiplication first. So 4 to the 3rd power times 4 to the 4th power is going to be 4 to the 7th power, and then divide by 4 to the 5th power. Each equals 4. Base stays the same. 7 take away 5 is 2. And then evaluate is 4 times 4, which is 16. Okay. If you have one that looks like D, where you have it written like this, and you're going, oh my gosh, I don't know what to do. Yeah, you do. Take it one step at a time. Simplify the top. 6 to the 5th power times 6 squared is 6 to the 5 plus 2 is 7th power, over, do the bottom, 6 times 6 to the 3rd power, so that's 6. And it's understood when we have a number by itself that there's a 1 there, so 6 times 6 to the 3rd power will give me 6 to the 4th power, and then now we're going to do the division. So 6 and 7 take away 4 is 3. I should have mentioned that earlier. Whenever we have a number or a letter by itself, it's understood that it has an exponent of 1. Because if our answer is 6, when we're doing any of these, our answer ends up with an exponent of 1, then it's 6. So remember, there's always an exponent of 1 there, basically. Okay, so all you have to do is just do one step at a time. Do the same thing when we're working with letters. So b to the 5th power times b to the 3rd power, base stays the same. b, 5 plus 3 is 8. Okay, x to the 8th power divided by x to the 4th power. Quotient rule, subtract the exponents. 8 take away 4 is 4. So x to 4th power. E, product rule, m 5 times 2 is 10 m to the 10th power. And we can't expand these, like expand them out. We can't factor them out and we can't multiply them because they're variables. So they just stay as variables. Okay, so same thing. We do the same thing with numbers and letters. Okay, so that brings us to key question 14, and the rules are right here at the top. Any base to an exponent 1 is equal to itself, so make sure you look at that. Any base to the exponent 0 is equal to 1. Then we have the product rule. To find the product of powers with the same base, add the exponents. Quotient rule, to divide two powers with the same base, subtract the exponents. And the power rule, to raise a power to an exponent, multiply the exponents. Okay, so the rules are all there, and then you have a couple for each to do. Watch this one. First one, you're multiplying, so that's your product rule. Second one, you're dividing. Quotient rule. In C, you've got something that looks like this. This means division, so you're still using your quotient rule. D, you've got brackets around the terms. Remember we talked about that in lesson 1. That means multiply, so that's x to the 4th power times x to the 4th power. So there's your product rule. G, you've got F and G, you're using your quotient rule. There's brackets, so that means Q2 times 3. And then in I, looks complicated, but remember, do one thing at a time. Do the top, A to the 6th power times A to the 3rd power. So you're going to use your product rule first, and then you're going to divide. So quotient rule. Okay, so moving on. So the next thing we're going to look at is the order of operations. So in your lesson, order of operations starts on page 10. So page 10, 11, 12, and 13. Support question 3 is on the bottom of page 13. So make sure again you do your support questions. Okay, so order of operations. Now, I touched on this just a little bit a minute ago when we were looking at doing 2 operations in one problem. So we did a multiplication and division. So we did, I said, do your multiplication first. So the order of operations, first of all, operations, I think we talked about this, are things like addition, subtraction, multiplication, and division. So other operations include squaring, finding the square root of, etc. So when you add 2 numbers together, you are performing the operation of addition. When you multiply numbers together, you are performing the operation of multiplication. So what is the order of operations? The order of operations is the rule for what operations should be done first when there are several operations within the same equation. So you can't just look at them and go, well, I feel like I'm going to do this part first, or I'm going to do this part. There is a specific way to do it in order to get the correct answer. So applying the order of operations. So we use the acronym BEDMAS for the order of operations. So B is brackets, E is exponents, M is multiplication, D division, A addition, and S is subtraction. So that's why BEDMAS. Brackets, exponents, multiplication, division, addition, and subtraction. So first of all, brackets. When there are brackets, and there might not always be brackets, but when there are brackets, whatever is inside the brackets must be done first. The stuff inside the brackets may also need to be broken down according to the order of operations as well. It is even possible to have brackets within brackets. Okay, so complicated questions. Exponents. If there are exponents in the equations, these would be done next. Multiplication and division. If there's multiplication and division, they can be done together from left to right. In other words, it doesn't matter if you do division or multiplication first. So whichever one comes first from left to right, that's the way you do them. Same thing with addition and subtraction. From left to right. So if you do, even though BEDMAS says addition and then subtraction, if subtraction comes first, you subtract first. Okay, so here's a tip. A good idea when working with many operations at a time is to do a little portion of the equation at a time, rewriting frequently. For example, do the portion within the parentheses and then rewrite the equation. Trying to do an entire equation at once can often lead to mistakes. break it down into parts using the order of operations and do a little at a time. So let's look at some examples. So here's the order of operations. BEDMAS, brackets, exponents, division or multiplication from left to right, addition and subtraction from left to right. So here we have two expressions, the same expression actually, solved different ways. So the first one is solved from left to right. So starting with 6 minus times 3 and ending with 9 divided by 3. So 6 times 3 is 18. Then bring down everything else. Plus 4 times 9 divided by 3. 18 plus 4 is 22. And then times 9 divided by 3. 22 times 9 is 198. Then divided by 3 will give you 66. That is incorrect. The proper way to do it is using the order of operations. So B, there are brackets. So this is first. So 9 divided by 3 is 3. Then after brackets, exponents. We don't have any exponents. So next is multiplication and division. So here we have 2 multiplications. So when we have 2 multiplications, we have to go from left to right. So 6 times 3 is 18. Then in the next step, we can do 4 times 3, which is 12. And now we have 18 plus 12. We don't have any subtraction. We only have addition. 18 plus 12 is 30. This is the correct answer, not 66. So you have to make sure you do it in the correct order. Okay, so we'll do a couple of examples. So we've got 10 divided by 5 times 5 minus 4. So BEDMAS B, brackets, there are none, so I can skip brackets. E, exponents, there are none, skip that. Next is D and M, division and multiplication. So I have both division and multiplication. So division comes first, so I'm going to do division first. 10 divided by 5 is 2, and then I'm going to rewrite the rest of the expression. Now I'm going to do, I've got multiplication and subtraction. I do multiplication first. 2 times 5 is 10. Subtract 4. And then addition and subtraction are last. I only have subtraction. 10 take away 4 is 6. Okay, so that's the correct answer. Next one, let's look at number 5, because number 5 has brackets. So B, brackets first, so I have to do this first. 12 plus 2 is 14. Bring down the rest of the expression, rewrite it. Now I've got addition and division. Well, division and multiplication become before addition and subtraction. So 14 plus, now I do my division. 8 divided by 4 is 2. And now I do the last step, which is addition. 14 plus 2 is 16. Okay, let's go down here to number 9, where we've got lots of stuff going on. So number 9, we've got brackets, we've got exponents, we've got addition, and we've got division. So first thing we do is brackets. So 6 plus 5 is 11, and that's squared plus, and I'm going to do the brackets in the same step. 24 divided by 6 is 4. Okay, so I've got my brackets done. Now exponents is next. So 11 squared is 11 times 11, which is 121 plus 4. So my answer is 125. Okay, let's do the last one, number 12. 2 and times, because there's nothing there between it. It's not 2 plus or minus. It's, if there's nothing there, that means 2 times. So 2, and I'm doing my brackets first. 10 plus 3 is 13 plus 5 squared. Now next I'm doing exponents. 2 times 13 plus 5 squared. 5 times 5 is 25. Now I've got to do multiplication first. 2 times 13 is 26 plus 25. And 26 plus 25 is 51. Okay, so you follow the order of operations. So for key question, where is it? 15, the bottom of page 24 is the order of operations. So evaluate the following, take your time, make sure you follow BEDMAS, and rewrite often so that you don't end up getting mixed up, making lots of mistakes. I don't know why that page is there. Okay, so again, take your time with that. Okay, so that's it for our class for today and our class till after the Christmas break. I hope you all have an excellent Christmas holiday, a safe Christmas holiday, and I will talk to you in the new year. Miigwech.